Hi everyone, my name is Izzatu Farhini DM Azman, and today I will talk about the problem statement as well as the objective of our project. So, this report reviews about the designing and the development of the system that is applicable for the microprocessor based system. In other words, this project mainly focuses on the integration of the hardware as well as the software of the system. Now, let's talk about problem statement. As of today, Malaysia manufacturing industry has greatly relies on an efficient yet dangerously equipment, which is we call heavy machine. This matter, however, give a rise to a new predominant issue, which is the safety workers. The workers' safety is all in all directly involved within the production process, which involve the heavy machine. It is wise to know that the employees must be protected against these machine-related injuries at all costs, as it all could result in disfigurement, amputation, even death. Recently, on Borneo Post has reported on their online report that a brick factory worker has become the victim of this heavy machine when he was crushed to death at his workplace. Thus, upon taking this matter into consideration, our team has decided to focus this issue by setting up this project of a security safety alarm system for heavy machine by using microprocessor based system. Objectively speaking, our project strives to protect the employees as well as the safeguard against these machine hazards by reducing the percentage of accidents against this heavy machine. Next, we want to ensure that all the heavy machinery that is used within the factory has been fully implemented by the safety alarm system. And the third one, we want to give the awareness barrier to the workers when this machine is about to start its process.
Hi, my name is Muhammad Akmal Azri bin Azizai. So I will do a test for this project. So this is the coding that we will use in this project. In this coding, we have two parts of coding. For the first part of coding is buzzer coding. In this buzzer coding, we will use a loop where the buzzer will beep in 3 times. The buzzer will beep first time. After that, it will stop beep. After that, second beep, stop beep again. After that, the buzzer will stop beeping. So for the second part of the coding is motor coding. In this motor coding, after the buzzer beep in 3 times, the motor will run forward and it will continuous run. This process will be done automatically by 68K. So we will execute the coding into the 68K. So first we need to assemble the coding. If they have no error in this coding, it means the coding okay to run. So we press OK. After that, we run the emulator. This 68K terminal emulator will upload the coding into the 68K. So first we need find the PC control. We will press a space button to find a PC control. This is a PC control, program control. So after we find the program control, we press enter button to enter the code. We press F2. This file is we need to upload into the 68K so the project will run smoothly. Then we press enter button, and after that, when we have upload the coding into the 68K, we need execute it. So we find again the program control. After that, press enter button. After finishing this process, press enter and the alarm system will start to operate.
Okay, for my part, I will explain the operation of our board after the coding of the program executed by the processor. Okay, let's look at the board. Okay, the first one, after we execute the first line, our buzzer will start to work and will making noise for 3 times. It will buzz for 3 times. That indicates the alarm at the industrial factory in any commercial factory. So after our buzzer buzz for 3 times, our motor will start to work. While our buzzer in progress, the light will be on as indicate as the safety warning. But when the motor starts to be in work, the light will be in red as the danger warning if someone's get near to the motor.
Saman bermacam kontainer. Ha? Kalau bekas apa ni kontainer? Kontainer. After the delay, there will before protection of power reverse to mark the one.
For the Q&A, I have 2 questions that I want to ask. For the first question, why do the alarm system does not have a manual switch during starting program?
For this system, the system does not include manual switch during starting process because we want to minimize human interaction with the system. This is because human interaction can have effects that can bring problems such as delays. If a human controls the timing of the buzzer, it will not be as accurate or precise as a machine can do. So it will bring many problems in the future.
Okay, for the question number 2, how do you want to stop the motor in case of an emergency?
Okay, another good question. In contrast to the first question, the motor had to be stopped manually or with the interaction of humans. This is because only a human can detect danger that is coming while the machine can't do it because it can't handle the emergency very well. It needs a natural response from a human to push the emergency button. In this case, we use a reset button that is present in the CCAK. This button will stop any action that the circuit is performing and give a safer zone for the safety step to be done. Here we can see the simulation. The motor stopped after the reset button had been pushed.